two-speed kitchen exhaust fan often uses two hot wires from the same power leg plus a neutral to achieve different speeds. The higher speed is accomplished by putting the two motor windings in parallel. When only one winding is used, corresponding to the low speed setting, the effective resistance is double that of having both windings connected in parallel. This principle can be understood through Ohm's law, which states that current is equal to voltage divided by resistance, represented as I equals V over R. By having the resistance through the parallel connection of the windings, the current effectively doubles, assuming the voltage remains constant. The doubling of the current directly leads to a stronger magnetic field within the motor. The strength of the magnetic field is directly proportional to the current flowing through the windings. With the magnetic field strength doubled, the torque produced by the motor also doubles. Torque is the rotational force that drives the fan blades. The increase in torque translates to a higher rotational speed of the fan. In essence, the use of two hot wires allows for the selection between two different motor winding configurations. One configuration, using a single winding, provides higher resistance and lower speed. The other configuration, utilizing both windings in parallel, provides lower resistance and higher speed. This is the underlying mechanism by which the two-speed kitchen exhaust fan operates. Understanding this principle requires understanding the relationship between voltage, current, and resistance, as well as the effect of these electrical parameters on the magnetic field and torque produced by an electric motor. To elaborate further, consider the behavior of the motor windings as inductors. Each winding possesses inductance, which is the property of an electrical circuit to oppose changes in current. When the windings are connected in parallel, the total inductance of the circuit is reduced. This reduction in inductance also contributes to the increase in current flow when both windings are active. The overall impedance of the circuit is lowered, where impedance is the total opposition to current flow taking into account both resistance and reactance, which is the opposition due to inductance and capacitance. The motor's design is specifically tailored to function efficiently at both low and high speed settings. The wire gauge, number of turns in the windings, and the motor's physical dimensions are carefully chosen to optimize performance and prevent overheating. The use of two separate switches allows the user to select the desired speed based on the ventilation requirements. When the low speed switch is activated, only one winding is energized, resulting in reduced power consumption and lower fan speed. When the high-speed switch is activated, both windings are energized in parallel, leading to increased power consumption and higher fan speed. It is important to note that the neutral wire serves as the return path for the current in both low and high-speed configurations. The neutral wire provides a low resistance path for the current to flow back to the power source, completing the electrical circuit. The gauge of the neutral wire is typically selected to handle the maximum current drawn by the fan at its highest speed. Electrical safety considerations are paramount when dealing with any electrical appliance. It is crucial to ensure that the fan is properly grounded to prevent electrical shock hazard. The grounding wire provides an alternative path for current to flow in the event of a fault, such as a short circuit. The grounding wire is typically connected to the metal chassis of the fan and to the grounding system of the building. Regular maintenance of the fan is also important to ensure its safe and efficient operation. This includes cleaning the fan blades and motor housing to remove dust and debris, which can impede airflow and cause the motor to overheat. It is also advisable to periodically inspect the wiring connections to ensure that they are secure and free from corrosion. If any signs of damage or wear are observed, it is recommended to consult with a qualified electrician to perform the necessary repairs. Furthermore, understanding the motor's nameplate information can provide valuable insights into its electrical characteristics. The nameplate typically includes the voltage rating, current rating, frequency, and horsepower of the motor. This information can be used to verify that the motor is being operated within its specified limits and to troubleshoot any potential problems. In summary, the two-speed kitchen exhaust fan utilizes a parallel winding configuration to achieve different speeds. The parallel connection reduces the resistance, increases the current, strengthens the magnetic field, and ultimately doubles the torque, resulting in a higher fan speed. Safety precautions and regular maintenance are essential to ensure the safe and efficient operation of the fan. Electrical schematics and diagrams can be helpful in visualizing the wiring connections and understanding the flow of current in the circuit. Consulting with a qualified electrician is always recommended when dealing with electrical work. This explanation delves into the fundamental electrical principles that govern the operation of a two-speed kitchen exhaust fan, providing a comprehensive understanding of its functionality. The relationship between voltage, current, resistance, inductance, and impedance is crucial in understanding how the motor achieves different speeds. By manipulating the winding configuration, the fan is able to provide both low and high-speed ventilation options. Remember to always prioritize electrical safety and seek professional assistance when necessary. The two hot wires, in conjunction with the neutral wire, create the necessary circuitry to control the fan's speed. The switches act as control mechanisms, allowing the user to select the desired winding configuration and, consequently, the desired fan speed. This design provides a simple and effective way to regulate ventilation in a kitchen environment. The design is common because it allows the manufacturer to use a single motor design for both speeds. The differences in speed are achieved by changing the electrical characteristics of the motor circuit. It is important to understand that the motor's performance is affected by various factors, including the voltage supplied, the load on the fan blades, and the ambient temperature. These factors can influence the motor's speed, current draw, and overall efficiency. Proper installation and maintenance are critical for ensuring optimal performance and longevity of the fan. It is recommended to follow the manufacturer's instructions carefully when installing and maintaining the fan. Regular cleaning of the fan blades and motor housing can prevent the buildup of dust and debris, which can reduce airflow and increase the risk of overheating. In addition to the electrical aspects, the mechanical design of the fan also plays a significant role in its performance. The shape, size, and angle of the fan blades are carefully designed to maximize airflow and minimize noise. The motor's bearings and lubrication system are also important for ensuring smooth and quiet operation. By understanding both the electrical and mechanical aspects of the fan, one can better appreciate its overall design and functionality. It is also important to note that the efficiency of the fan is affected by its design and operating conditions. A more efficient fan will consume less energy and produce more airflow. When selecting a kitchen exhaust fan, it is advisable to consider its energy efficiency rating. Energy-efficient fans can save money on electricity bills and reduce environmental impact. Furthermore, the noise level of the fan is an important consideration, especially in residential settings. Some fans are designed with noise reduction features, such as sound dampening materials and optimized blade shapes. Choosing a fan with a low noise level can contribute to a more comfortable kitchen environment. In conclusion, the two-speed kitchen exhaust fan is a sophisticated appliance that utilizes electrical and mechanical principles to provide efficient ventilation. Understanding the underlying concepts can help one to appreciate its design, operation, and maintenance requirements. By following safety precautions and performing regular maintenance, one can ensure the safe, efficient, and long-lasting performance of the fan. The use of two hot wires and a neutral wire allows for the selection of two different speeds, providing flexibility and convenience for the user. The design is a testament to the ingenuity of electrical and mechanical engineering. The parallel connection of the motor windings is a clever way to reduce resistance, increase current, and boost torque, resulting in higher fan speed. This principle is applicable to various other electrical devices and motors. By studying the two-speed kitchen exhaust fan, one can gain a deeper understanding of electrical engineering principles and their practical applications. The fan serves as a tangible example of how these principles are used to solve real-world problems. It is a valuable learning tool for students, engineers, and anyone interested in electrical technology. The topic of motor windings and parallel circuits is a fundamental concept in electrical engineering. Understanding this concept is essential for designing, analyzing, and troubleshooting electrical systems. The two-speed kitchen exhaust fan provides a simple and accessible way to illustrate this concept. By examining the fan's wiring and operation, one can gain a practical understanding of how parallel circuits work. The fan also demonstrates the importance of electrical safety. Working with electricity can be dangerous, and it is crucial to follow safety precautions at all times. Proper grounding, insulation, and circuit protection are essential for preventing electrical shocks and fires. The two-speed kitchen exhaust fan serves as a reminder of the importance of electrical safety in the home. It is advisable to consult with a qualified electrician when dealing with electrical work. Electricians have the knowledge and experience to ensure that electrical systems are installed and maintained safely and correctly. Attempting to perform electrical work without proper training can be hazardous and can lead to serious injury or death. The two-speed kitchen exhaust fan is a relatively simple appliance, but it embodies important electrical engineering principles. By studying the fan, one can gain a deeper appreciation for the complexities and intricacies of electrical technology. The fan is a testament to the power of human ingenuity and the ability to harness electricity for practical purposes. It is a valuable addition to any home and a testament to the advancements in electrical engineering. The two-speed functionality provides versatility and convenience, allowing the user to select the appropriate speed for their needs. The design is both elegant and functional, demonstrating the importance of both form and function in engineering. The two-speed kitchen exhaust fan is a product of careful design, engineering, and manufacturing. It is a testament to the skills and expertise of the people who created it. The fan is a valuable asset in any kitchen and a reminder of the importance of innovation and technology. The principle of parallel windings is used in many different types of motors and electrical devices. The two-speed kitchen exhaust fan is just one example of how this principle is applied in practice. By understanding the underlying concepts, one can better appreciate the versatility and adaptability of electrical technology. The fan is a valuable learning tool and a testament to the power of human ingenuity. It is a reminder of the importance of education, innovation, and collaboration in the field of electrical engineering. The fan is a product of continuous improvement and refinement, reflecting the ongoing pursuit of excellence in engineering. It is a valuable asset in any home and a source of pride for the engineers who designed it. The two-speed kitchen exhaust fan is a symbol of technological progress and the ability to improve people's lives through engineering.